Unseen Talks. Success stories with a bite of ADVACAM inside.
What unseen will be revealed in this episode. Our guest leads innovative robotic missions. He designs rovers for Moon or Mars exploration, and he is also a huge fan of sci-fi movies and dreams about bringing them to real life. Get ready for a chat with a man who is building robots to work for us on the way to the stars. Hi, my name is Martin, and I am so excited to welcome here Maneesh Verma, who is our guest in this episode of Unseen Talks. Hello.
Hello.
And I'm also very happy to have here my friend and my colleague David Hladík.
Glad to be here again.
As he is our space applications expert at ADVACAM. Well, Maneesh, what concepts from the sci-fi movies would you like to see in the real life space exploration?
First of all, thank you for having me here. It's an absolute blast to be here and talking about my life and also the work that I do. I think the fascination with sci-fi movies began when really early age. I think half of us, basically when Star Wars or Star Trek kind of came up. And the biggest inspiration from that is something like have a buddy robot kind of a thing. I think something like what R2-D2 is. It can solve a lot of generic problems, but also a very specific thing is always by your side. I think this is something which we all kind of desire to have. We start with toys, and then if the toys could talk and can actually move around by itself, which is technically a robot, that's it. That's all what we would like to have.
How far are we actually from R2-D2?
I think quite a lot.
Okay, so it's up to you to come there. Why do robots play such a crucial role in extraterrestrial space missions?
Yeah, as you know, that a lot of places, even on Earth, and space is definitely hostile to the human body and to everybody from Earth. And space exploration is very difficult. It's very time consuming. Planets are very far, and humans are not really built to explore on such a wide time scale and such harsh environments. And we need to send someone or something beforehand to survey or explore the world on our behalf as an extension. And robots play that role very, very well. And as you can see, that robots can play multiple roles. They can go everything from logistics to science to construction, exploration, maintenance. And they're always useful even before humans will reach, while humans are there, and after humans have been to the place. So robotics play an exceptionally crucial role in space exploration.
Do you think there will be a point in the future where robots will be actually more useful than human on site?
This might be controversial because I design robots. The answer is yes. I do not want humans in my loop. They are cause of mostly errors. But I think robots have their value when they work with humans, because humans bring a very different aspect of a skill set to the mission itself. Robots are limited, as of now, at least in a lot of variety, which humans are not. But the driving force of all this exploration is to send humans. Mm-hmm. So if humans don't have the inspiration to go to someplace else, robots will also not go there. Mm-hmm. So irrespective of humans are useful or not in that specific mission, humans will always play a vital role.
Yeah, if we look at the robots or rovers that are currently working on the surface of Mars, for example, I see them mostly like explorers. Yeah. They are do exploration and maybe some experiments. Yeah. But how far we are from, I don't know, building robots or safety robots or transportation robots?
I think so there's a lot of people in the US and also in Europe working on these concepts to bring, because going from a car-sized rovers, which are on the moon right now, to making basically truck-sized rovers is not as simple as people think. It's an exponential leap, basically. And we are not close enough purely because we don't have... So having the rover itself is not the problem. It's the entire logistical chain that has to actually compensate for that need. So if you want to send a truck to Mars, you also need the rocket for it. You need the network for it. You need there's a lot of auxiliary systems you need to make just that rover go. And that is going to take some time. So we can build the rover today, that's fine, but everything around it might not be accessible to us just yet.
Yeah, I know you have participated in several space analog missions that simulate an actual astronaut or rover mission to other planets. It was, for example, the AMAD-24, Asclepios 4, or the CHILICE 2 mission. What is the purpose of these analog mission? What do you test there, and what location actually it was?
Yeah, actually, a lot of people are unaware that there are a lot of locations on Earth which kind of simulate or are very similar in terms of isolation or landscape and materials that you find, like infrastructure, like caves, which are replicable on Moon and Mars. And we go to these sites, something like in Armenia or in Iceland, you can see one of the lava caves, basically, which is for the CHILICE 2 mission. You can put a habitat here, and you can have 4 astronauts sit there and do like 7-day cycle. And it simulates basically living inside a cave on moons. So they don't have daylight, basically, and then you basically practice or you kind of demonstrate different technologies like rovers or medical equipment or collecting samples, protocols, procedures, and just psychological effect that these isolations and missions can have on the astronauts and how we can cope with them for the astronauts for long-term missions. Of course, they do only 7 days. Missions can be 30 days, but yeah, the scalability is there.
Mm-hmm. Is there any analog mission in Czech Republic? Do you have any experience with it?
I do not have personal experience with it, but I think so as you said, CHILICE 2 mission. So there is actually a Czech company which is called IC Space. They started, I think, a couple of years ago. So there is a company in Czech trying to commercialize and bring the expertise of doing analog missions. I'm not sure if they have a planned mission in Czech as such, but there is somebody working on it actively in your space industry.
Are these robots, these companions, autonomous, or they are usually remotely controlled?
So we would like them to be autonomous. Currently, that's not the case. So it is teleoperated. Usually, the person whom the rover is kind of accompanying, he's the one who's controlling it, or somebody from the habitat will control the rover, just acting as a companion, but in a robot form. So you can have, let's say, I'm going on an EVA, and I want David to come with me, but he has some work on the habitat, but I still want his expertise. So he can talk to me, see 3 things through the robot, and he can still control the robot. So I can call the robot David, and that should just work.
What people don't realize usually is that on the other bodies, there are no GPS. There is no GPS.
Yeah.
So the navigation is a problem.
Yeah. Absolutely. So the first thing anybody talks about in robotics on off-worlds and like caves, because this is a GPS-denied environment, is you use localization data as much as possible. And this is why humans are actually important to be alongside robots, because we perceive an environment very quickly through experience. But there are technologies that can cope with this kind of technology without having GPS.
And what is the biggest problem now when it comes to navigation? Like, can you face these problems even here in the analog missions, or is it like a blank thing?
No, absolutely. You face them here on analog missions, and as I said previously, that they simulate the environment, both in terms of infrastructure and technology availability. So you go into a desert, you go in a cave where GPS is not there. And the way you solve them is pretty much you explore. You send the rovers out, you explore, you make a map. So here you can see in like Amity that they are trying to send. Actually, this is one of the rovers from the mission. This is not mine rover actually. So they are basically guiding the robot. You can see that the person is teleoperating the rover and guiding it towards the path. But at some point, if the rover just makes a map out of it, the next time you don't need the astronaut to do it. So that's one way of doing it. The second way that it's doing autonomously everything, we call something called SLAM. Biggest problem is there is no global coordinate system to see where it is actually. So it's everything relative, but it works if you know the landscape.
All right. In some of your projects, you have used the technology of so-called human-machine interface design. It's connected to the remote control we just discussed. That was specifically in the HUMANISE project. What this was about?
So the HUMANISE project actually started about 2 years ago. It was actually an outcome of collaboration between me and my colleague, co-PI for the project, Lucia Rajkova, who's just finished her PhD actually at the Mesrek University here. She's from Brno. And actually, we were in the CHILICE 2 mission, and I came with my rovers, and she came with her experiment for stress analysis. And we were just talking on how can we combine these two things, because during the mission I realized that robots play a much better role accompanying the astronaut rather than making everything autonomous. And then we needed to make so why would an astronaut take a robot, because sometimes they feel like it's a burden. I have to carry this robot with me, I have to operate it. So I said, okay, if it's not intuitive enough, nobody's going to use it anyway. So robots have to be intuitive. And I was like, how do we measure this intuitiveness scientific way? Yeah, you can ask the astronauts, but astronauts are not very truthful half the time because they don't know how the body is reacting. So luckily, Lutze was like, hey, who knows how to measure stress and how to calculate what the body is actually telling you in truth? And I said, okay, let's combine our study and let's start a new project and say that I can make the machine as intuitive as possible in terms of controlling. So we can use different technologies like BCI, VR, and joystick and make it more intuitive that there is less training time. And it basically becomes the moment you start the rover, you know what to do, basically. That's intuitiveness. And her research would help to assess how well that intuitive system is going through. Does the workload actually increase or decrease with this intuitive control?
And if I'm not mistaken, your goal, I think we talked about it several months ago, your goal was to make the robot like a companion to the astronaut, that it would not help him only to do the tasks, but even to actually help him with his mental state.
Yeah.
Because he's not alone there, he has something to rely on, etc.
Yeah, absolutely. Actually, this was one of the experiments for Chirai's 2 mission, where we realized that the buddy system with a robot works really, really well. Especially if you personalize the robot for the astronaut, then it really works like a buddy.
Do you put a stickers on it, or
They
how do you personalize?
They can. I have once the astronauts have the robots, they can do anything with it. They can paint it, they can give it a new name. Okay. Wow. For me, it just works.
Unseen Talks.
You mentioned that there are several technologies. It was brain-computer interaction, BCI, virtual reality, and haptic gamepad controller, like PlayStation gamepad. Yeah. Okay. Well, what performed best?
So that's the question. That's what we have not been able to assess. It's like a research gap. Even for NASA and ESA, they also do not know which is the best controller for which type of task. So it cannot be that you use all the controllers for all different types of tasks for tele operations. There's some tasks are better suited for one type of controller, like VR. You can see here, VR is very useful for immersive feeling when you're exploring a map.
There is a camera on the rover, and it's first person.
Yeah,
basically.
Exactly. It is the first person, but you can change it with a 3D camera. I mean, the camera technology has gone way beyond what we can imagine. We can also integrate LiDAR into it, so you can see in dark and you can see more detail, basically. But that immersive feeling comes when you can feel in a 3D environment.
You see like a bat.
Yeah, you can. Well, bat is sonar, but maybe not.
Yeah, of course.
Yeah.
What about the brain-computer interaction? What is it?
Yeah, so what we understood, so we are doing BCI in partnership with University of Cardiff, and they have been doing a lot of research already prior to when we joined them. They were doing it for robotic arms. And the thing with BCI is that it has a lot of advantages with it frees up your hands to do other things, right? And mostly, you were asking about sci-fi things that you want to bring to life. This is one of them. So you can see...
You've got a helmet with some sensors and
yes.
It's reading your mind? Or
yeah,
what?
Well, it's not reading your mind. It's reading the brain signals, which you can train the computer to interpret into certain things. So luckily, we are very lucky to live in a world where you have companies like Neuralink already doing something advanced, which is commercial. There's always been medical application for it, but not coming to the field application.
Okay, so I'm thinking the turn left, and it does it.
Yeah, exactly.
Well, really?
How precise is it?
Currently, not that much, but it also depends on how much you train. I mean, the technology is expanding, is growing exponentially. So today we might say, it's about 50% accurate. In 6 months, it just might be 80% accurate. So the technology is going really quickly, especially with artificial intelligence, machine learning coming in. We have astronauts that can put data into the system, and then the more the system understands, the better it can remove the noise from the signal, and then it will say, okay, so you can think 3 things maybe, but it will know that, okay, you're thinking left actually. But that's only the first step. So this adds to the intuitive control. The machine might also know that, okay, there's only one way to go anyway. If you think right, it will not go right. You were actually thinking left, so it will go left. So that's the intuitive thing, that the machine is aware as much as you are aware of it. It's just not doing the thing you have not told it to do.
It's a bit scary
Yeah,
at the same time.
I wanted to ask you if you already have some feedback from the astronauts. What do they think about it? Because it's like someone is reading my mind. I don't really like this
I
idea.
think if you so we haven't asked these tough questions to the astronaut yet. If you ask me the same question a year from now, exactly, we will have your answer for it, because we are starting a program with a few astronauts, not astronauts, few analog astronauts, to actually give us the feedback, train with us, collect their data, and train our system to make sure the BSAT system is actually as accurate as possible. Because every person thinks in a different way, so the signal pattern is a bit different, and this is how we will try to get. But do not worry, we're not training machines to say run and it runs. No, we will delete that signal.
Hello again, this is Martin, Maneesh and David, and we are talking about rovers, space exploration and so on. I would like to turn page to the cosmic radiation. Is cosmic radiation one of the important reasons why human capabilities on the other space bodies are limited?
Absolutely. So as I said in the early, that it's a very hostile environment. One of the things that makes it hostile is the presence of very harmful radiations. So here on Earth, we're protected by the atmosphere. Many planets and moons don't have that atmosphere to protect us. Also, the magnetic field is not there. So definitely, this is one of the harmful things that we have to avoid.
Yeah, so in the ideal scenario, the man is covered in a shelter, and the robot is doing the hard work outside.
Yeah, absolutely. So you can make a habitat which is underneath like a cave, or they are covered, or if it's on the surface, they're covered with the lunar dust as like a protective layer, or maybe water or some actual material. But yeah, robots are the ones that do the risky job outside.
Plus, I think like the most important thing is that the robot can actually assess and explore the environment beforehand.
Yeah.
Because we don't even know if this is more radioactive than the other place, and the robots can do this
Absolutely.
without any
Like,
harm. Yeah.
you send robots first to measure the radiation level in a cave or some hotspots that you want to go to, and if everything looks normal, then you send the human for it.
And obviously, therefore, at ADVACAM, we are very, very proud that you choose our radiation detectors as the main payload for some of your rovers. Why have you chosen this technology?
Well, first of all, I think the sensor fits on our rover because we are building micro rovers. We're not building half a truck size of rovers. Second is that it has flight heritage already, and the sensor can detect the exact radiation that we actually want to measure. So it fits our science requirements. And basically the last thing is that you guys are extremely friendly and nice to us.
Okay, maybe David could now describe what's inside the device.
Basically what we see, the dark part of the image, this is the sensor, this is the camera, and all the rest, even though it seems a little bit bigger, all the rest is just a protective case, because we are preparing for a specific mission, so we needed some cooling, we needed some protection from dust, etc., etc. But otherwise, the detector itself, Minipix, is basically the size of a flash drive. So yes, that's exactly it. So as Maneesh said, like even the nano rovers or mini rovers, there is always plenty of space to put like a small device like this.
Where are these supposed to be tested?
So initially, definitely it will be tested in the caves of Iceland. It will be tested in maybe Hawaii, and it's also in the deserts of US. And we want to see mostly in the operational wise how this data is actually used in the mission itself. How this data, when it's added to the flight plan, how it can enhance the planning of the mission for the astronauts.
So you will use the background, no other artificial sources of radiation.
No, not yet, but it is possible, because you always have unseen consequences of having the right instrument at the right place. Maybe there are other instruments which are for radiation, and then this sensor just sitting there detects like a leak or something. So that can happen, and these things are very common in these kind of missions, that you have a unthought consequence of something else interacting with something else.
Yeah, I think the main goal was, at least from our part, to learn how to integrate it into something small like a rover and make it functional and actually efficient. So that's what we want to learn.
Yeah. And I think on top of that, how to streamline the data collection.
Yeah, I was just about to ask, what are you going to do with the collected data? And how are you going to process the data from the detectors?
Yeah. So I should clarify that rovers should always be used as tools to the missions. You should not make the mission over the rover. That's my personal thinking. And the more data we can collect through these rovers, the better it can enhance the operation of the mission itself. And because rovers can have many sensors as we wish, and one of them turns out to be radiation, it can be temperature sensors, it can be humidity, light sensor. And if you combine these data together, you can create like a profile of the terrain that the EVAs will go on. And that's very useful for either the planning of how long the EVA should be, or what are the consequences that you can do after the mission, because you have this data to compare and see what the time, if something happens, these were the conditions that this event happened. And that data becomes extremely important.
Yeah, in context.
In context, absolutely, in context. But to provide that context, you need this tool to begin with.
Yeah. Actually, I was asking because ADVACAM has developed recently a new post-processing software called Trax Engine. And it could be maybe beneficial for such emissions.
Definitely, yeah. I wanted to say that basically like the normal goal of measuring radiation we can do with a simple dosimeter. But the added value of this sensor, of our Manipix, is like many other processing tools. And one of them is what we are looking at right now, where basically it's like a radiation camera. So we can acquire a raw image of mixed radiation field. We don't really know what is there, what are the components of the radiation field. And you can see it here on the right side of the image, where it's like clusters of pixels and hits of different particles, everything meshed together. So we need some tool that can distinguish between different particles, and that's exactly what we developed. Here on the screen, basically we can see that from this simple image, we can extract the standard energy spectrum, which is on the left bottom. But then we can also differentiate between different particles. So on the top left, you can see that we can differentiate between electrons. Those are the thin worms that you can see in the photo, and protons or heavy ions. Those are the bigger blobs. So that's exactly why our Manipix is a good and crucial tool for these explorations. Because if there is unknown radiation field, we can basically make a decomposition and have a good information about what's probably there.
Mm-hmm. Okay, is the radiation monitoring important also for the robot itself? I mean, could the radiation harm the electronics or communications capabilities?
Yeah, absolutely. I mean, as you know, because you also work in the sensor world, that they can be radiation tolerant or they can be radiation hardened, the electronics itself. But because these are CubeSats, they are micro rovers, we use the CubeSat technology for micro rovers. Most of the electronics can be either just radiation tolerant, right? So they can still have errors in them because of radiation. So you need a reference of when this event happened. And if you have something as your sensor, then it gives absolute time and the exact information on why this system failed, most likely. But it's not only important for the rover, it's important for the payloads that we carry, which are sensitive to radiation. And then you need a sensor to have in context that when it actually
I just want to clarify for someone else, radiation tolerant, radiation hard. Radiation hard is like 1,000 times more expensive.
Yes.
So if you have something that is radiation tolerant, we know that it should survive. It's like 99% sure that it will survive, but it doesn't have the stamp of being radiation hard, and the price goes dramatically low. So.
And I guess at the same time it's much heavier.
Can be. There's different materials used and everything.
As far as I know, so far you have done several simulations here on the Earth, but your ultimate goal is to get your rovers and your equipment up there, right? Yeah. Tell us when your rovers will be up there. I don't know, on the Moon or on the Mars.
I think I'm still trying to spread my wings on like Earth. Going to space is like a long road for now. I think for us, we are aiming for doing more extreme environments on Earth itself, which includes Antarctica. which is the perfect analog for Moon or for Mars. Depends on the opportunity. It depends when there's an opportunity, and depends how far we are in with our rover technology. Most likely, it will be after 2028-ish, because then we have proven our technology here on Earth.
That's far away, but first thing first, what are the very first steps ahead on your path?
So first is that we need to collect a lot of data about our own capabilities. So of course you can make the technology as much as better, but you also need the team which can actually operate the system, and that takes time to get the experience. So for this year at least, we are focusing on just making the system and the rover and integrating your payloads and having more than one rover finished for the mission. And next year we are going to 3 different missions, mostly analog missions. One is in US and 2 are in Europe, and they are mostly based on swarming. So we are doing multi-rover missions then, and this is where if we have more than one sensor, we can collect as much data as possible.
By the way, when you say we, who is it?
Yes, it's my brilliant teammates in the HUMANISE project. So we are a very small team composed of mostly engineers, but also people from a lot of partners and collaborators from universities and companies. One of them is you, of course, but we have partners from France, from Iceland, Spain, and they're all doing their part, mostly in the research part of it and data analysis, while I think about 5 engineers in Delft are working on building the rover and the software system for it.
I guess it's very international.
It is extremely international. Yes.
And you are based in Netherlands?
I'm based in Netherlands.
Let us see behind the curtains how look the work of the team, of international team consisted of very busy people.
Yes, so most of us are students. So absolutely, they are packed from 8:30 a.m. to 5:30 in the evening, and then when they have some motivation and some energy left, they spend it on with us. We have some students working in Toulouse for us. We have some students in Delft. We also have some students working in Cardiff. And these students are all working on their own schedule. We have monthly meetings to get up to date. We have some staff members working out of their own full-time job, sometimes also sacrificing family time. So thank you for that. But also we have partners like you. When we ask you to develop something for us or help us, then you're always there. And behind the scene is chaotic, I would say. If somebody says that plan works, no. But we try to keep everything intact because we have a goal. So as I said, we have a goal next year for a mission. So everybody knows their role, what it takes to finish to that goal.
Yeah. And our cameras will be involved already in some of these missions?
Yes. So we are sending 2 rovers to this mission. One of them is the robotic arm rover, and the other one is the sensor rover, which is your sensor on board.
Oh, great. So we are looking forward for the data.
Same here, yes.
Are we sharing the data with us, by the way?
Yes, absolutely.
Is it useful?
We'll see. I mean, still we are measuring on Earth, so we are not expecting any surprises. But as I said previously, it's more about learning how to do it, and then we can apply it into more serious business, like the moon, for example. That's like the holy grail, right? So that's what we are preparing for.
Or we find a buried nuclear wasteland.
Anyway, you are not only into rovers. I've heard that you're also going to send an actual human eye to the ISS and measure some radiation effect on the organ. It was a proposal.
It was a proposal. It was actually led by a professor in US, Indiana University, actually, and we met randomly in doing a conference, and we got on board with it. And yes, there is a plan, but unfortunately, the call did not get accepted because it has a very high risk on certain things. But we will continue pushing for the proposal. So basically, it's not us, but it's someone else maybe who gets there. But the eye, it's okay. Just to be clear, it's not actual human eye. It's like self-grown from a stem cell.
So that's still very interesting.
Yeah, so we do not pull someone's eye out. But that eye basically is supposed to go to ISS to see if there is radiation effect on the eye, and then we have your sensor next to the eye to basically have the context that what radiation is being measured. So we know that this radiation event at this point caused this kind of event into the eye. And if it goes well at some point, then we also send it to the moon.
Yeah, because there are some effects on the human sight quality.
Yeah.
For the astronauts experience it very commonly, right?
Yeah, absolutely. I'm no expert in it. I had like 6 hours of crash course with the PI of this project, but she was very kind to give me all the slides and everything, and I kind of understood that the eyes can create different kind of chemicals under different radiation and temperature also, but also because it damages the actual cells quite rapidly, and you can have mitigation plans to overcome this. The good thing is that there are mitigation plans that can overcome this, but to understand what mitigation plan has to be for when and how, that's what the experiments are supposed to happen.
And we can cover also the swarms. You're working on swarm collaboration of rovers.
Yeah.
Why?
So that's mostly because of my background. So like history defines you. So I worked almost 10 years at my university working on some aspect of swarm technology or multi-agent, as we say, technology for micro rovers. So when I left the team, I kind of got inspired by it, and I kept that expertise. But I see a very advantage in it compared to a big rover, basically. So I will never say that one idea should replace the other idea. Every idea has its own place and its own advantages and disadvantages. A large rover can carry a lot of payloads, can carry heavy payloads, high performance payloads for a very long time. And can support other rovers, which is smaller rovers, which is where the swarming
like mothership.
Like a mothership,
Okay.
Absolutely. So where this is where the swarms can play a role, because if you lose a $1.6 billion worth of rover because you crashed it, the whole mission is gone. But swarm rovers give you this edge where if you send 20 rovers or 100 rovers or 200 rovers, it's scalable. It's extremely scalable. It's relatively cheaper than sending a big rover. And the risk of losing 10 rovers is nothing compared to...
How large are these sparable robots?
Depends. You can go extremely like small, like maybe size of a eraser to size of an A4 sheet, or maybe about 30 kilograms, 40 kilogram size. Maybe that's where the limit should be. But the good advantage is that you can have it in so many different shapes and sizes and formats. You can have a snake, which goes like subterranean. You can have like a small drone that can hop. You can have the rovers that we are building with so many instruments like distributed across different rovers. So swarming has extremely high capability of helping us explore.
Maybe I have a challenge for you, implementing detector into snake.
we can make like some flexible one, yeah.
We have flexible solutions.
I wanted to ask for this, like, did you ever think about not doing rovers but drones? Because we have here experience with swarming drones without detectors, actually. So, like, did you ever have this idea? Like, what about using drones?
Yes, I do, but I can guarantee you there are better people at this technology than me.
But do you think it's complementary? That we would have like one unit on the ground, one unit in the air?
Absolutely. Yeah. I can tell you that this might not be a new concept, but when we started about 10 years ago, my professor used to always think, he thinks about robots like species. So you have different species. So you can have different rovers, but with different types, and they will still work together in a swarm. So now you can imagine that you have land-based robots, you have air-based robots, you have underground-based robots, and they can all talk to each other because they're talking on the same telecommunication protocol, which we as species cannot do that.
It's like the telepathy, right? It's the sci-fi again.
Exactly. So robots can do that for sure. So absolutely, you can have drones complement the land rovers complement an orbital robot, and they can talk to each other and distribute information.
Maneesh, your background is at the Technical University of Delft. It's obviously one of the best technical universities in the world. What is the environment at the university, and did they back you? And can you leverage your knowledge what you get during the education?
Yeah. As you know that I come from a Indian high school system. And then when I came to Netherlands, I did not expect this kind of environment. It was very supportive. It was very outgoing. It was very hands-on experience. Basically, TU Delft has a system of having student teams participate in worldwide top-tier competitions. And they give them the independence to do that. That's the biggest thing. The students can decide what to do, when to do, what competition to enter, how to do it, raise funds basically. So the learning experience that is immense. TU Delft supports you. There are multiple departments that can support you if you align with their goals, of course. Professors are very eager to get students out of these projects because they have experience which complement their master thesis or even the PhD to work at labs. And plus, as you said, the TU Delft has quite a big reputation in the world, and that helps when you contact companies that, hey, we are studying at TU Delft and we want to compete at this competition. Would you like to help us or partner with us? So everything that you asked, yes, TU Delft completely supports, helps, and in fact encourages us to take even out of this world ideas. Earlier this year, students were making habitats for the moon, and they competed in a competition. There were people doing solar cars, people building rockets. My background is in 10 years of building rockets. I mean, I joined TU Delft in 2010, a 17-year-old, never thought that I would ever build a rocket in my life. 3 months later, I was building a rocket. 5 years later, I was halfway to space. So
they just put you into.
Yeah. But that is what is needed, I guess, to get those hands-on experience. And I don't think there are many places in the world that you can build a large hybrid rocket or a liquid propulsion rocket on campus and then launch it. So definitely there is support from TU Delft.
Do you think that you would be able to mentor or give some advices to, for example, Czech universities? Because this is what we extremely like. Yeah. We have a good school system, but we like the hands-on experience and the independence, as you said, the opportunities. This is something what we like, and even in the mindset. So do you think you would be able to mentor someone from Czech Republic?
I would love to, because when I started myself, I had brilliant mentors with me, and I think they had brilliant mentors with them, and that kind of changes your attitude towards mentorship and helping other students. So absolutely, because if they were not there, I would not be sitting here. Yeah, that is absolutely given. So if I want somebody else to be here, yes, I would definitely love to mentor.
And you will not be here if you don't move from India more than 10 years ago. And you studied 14 years already 14 years. But as far as I know, the Indian space program is also very successful and ambitious. You have achieved some major successes in the last few years. The ISRO, for instance, successful landed the moon's surface with the Chandrayaan-3 mission. There was, of course, also the Pragyan rover, and you already have some astronauts in training. So why not come back to India?
Yeah. So
are you planning it?
Yeah, that's a better question, actually. Yes, I'm definitely planning to go back to India for several reasons. And yeah, one of them just inspires that ISRO is doing so well. I think India has been doing really well even before I came to TU Delft. I mean, that was the inspiration to get into space. When you're in India, you hear about Indian space missions more than what you would hear of international. At that point, they had already accomplished going to Mars. They had accomplished already going to, they had very ambitious astronomy missions. And they were doing a lot into their own GNS systems. And there were always plans, and those plans are the ones that tell you, okay, if I study today, then maybe in 5 years' time, you can be part of that plan itself. So that inspiration is always, and it's not me. I think it's every Indian student who wants to graduate as of today will have that inspiration. And ISRO just gives them another reason to do it. As far as astronauts go, that actually caught me off guard personally. Maybe I was not aware of the Indian space program that much since I moved here. But we were working with space missions in Europe, mostly to work close to with astronauts and everything else. But when Indians announced their astronauts, I'm like, okay, so we just leapfrogged 126 countries probably to have astronauts. So I can just go back to India and actually work with them. Yeah. So I hope there are other people like this who think like me who can just go back to India. But definitely, I would love to work with these astronauts.
But you have already contributed to some Indian projects already.
Yes, we did. So when I was a student at TU Delft, we were in collaboration with ISRO, and there's a very strong collaboration. And we were there for one of the launches in 2017, February. We gave some support from us. And I was working at that time at a CubeSat company in Delft, and we were part of one of these CubeSat missions.
Okay, Maneesh, thank you very much for coming in the podcast Unseen Talks. Thank you, David, for your contributions. And thank you, too, for listening to the podcast till the very end. And please stay tuned for more success stories with a bite of ADVACAM inside.
Unseen Talks are brought to you by ADVACAM, a world-leading producer of single-photon imaging and particle tracking cameras. We're imaging the unseen.